This conference will now be recorded.
We'd like to welcome you to our second in a series of educational seminars on networking for security applications. Seminar 1 was an overview on what followed on the specific areas that cover each of the technical aspects of network recording. In these seminars, we'll work off of that first one and we'll get into more depth in each of them. I want to remind you that the reason for these seminars is that regardless of the products that are connected to each end of your network, they are dependent upon the performance of the network itself. Also, regardless of whether you're in sales, design, installation, or technical support, everyone plays an important role in assuring the most reliable security performance with the least amount of potential problems. Our hope is by attending these seminars, you take away something that makes your job easier and more productive. Reminder that each part of the network is considered to be its own internal network. But as each interacts with each other, they affect the network as a whole. No part of the network can act as a standalone without affecting the network as a whole. In seminar number 2, we're going to be focusing on power over Ethernet, or PoE. This is perhaps the most misunderstood component of networking due to all the variations involved. Often we think about the IEEE standards, such as those applied to 802.3AF or AT, as fixed values. They are anything but. The process of determining how much PoE is required is made more complex by all the variations within the operations and the growing requirements for more power over those that consume within this standard. So let's take a look. We're going to be talking about PoE challenges, terminology, how PoE works, PoE standards, PoE safety features, PoE and cabling, and the power surge. So let's start with our challenges. So once again, the two major components of a network are bandwidth and power. And today we're going to look at power. As camera features have increased, adding more and more features to them, such as day-night, auto back focus, LED operation, and PTZ, the need for power has increased enormously. When we look at the system, we spoke about this in our introduction, it was based on Cat5 cabling. And in that, the distance of it and the type of cabling, which is 24 gauge, determined the amount of power that was transmitted from the source to the connected device over 328 feet or 100 meters. In the PoE terminology, of course, PoE is power over Ethernet. Essentially, there are 3 standards that are currently in play, and they're rather confusing because they cover a wide berth of power. 802AF provides 4 different power levels, or what we call classes, of 0 to 3, with the highest source power being 15.4 watts, and the standard is released. 802.3AT provides 5 power levels, again incorporating the first 802.3AF 4 levels, adding another one, which the highest power level is 30 watts, and that's a release standard. BT is somewhat of a mystery at this point because it involves different power levels ranging from what we call class 5 to class 8, all the way up to approximately 90 to 100 watts, but it's a standard that's in the state of flux right now. What is standard is the terminology used within the PoE standard and the terminology that we'll be referring to throughout this presentation. Power sourcing equipment, or PSE, is defined as the product, or in the case of a switch, the port that provides PoE power. PD is the component that receives the power, such as a camera. Now, when we use this terminology, and it's important whenever we refer to it, we are also including all the safety elements that are incorporated within the IEEE standard referring to PoE. And this brings us to the other term of an injector. When we use the term injector, which you will not find within the IEEE standard, it is essentially a wall outlet. It's providing power all the time without the protections that are embedded within the IEEE standard. And this means that if there is a short within the system, the only way to turn off the power is by means of having the PSE or the PD, the connected device, burn up. The detection pulse is part of what the procedure is to activate PoE. So basically, this is the way the system works. If I take a camera out of a box, it's essentially in the off position. If I program PoE power to a PSE and try to measure it, it's going to measure 0. However, when I take my Ethernet cable and I connect the two ends, the PSE to the PD, the first thing that happens is a voltage appears. This voltage can be called the detection pulse. And what happens is the voltage goes across the line, reaches the PD, which is essentially a resistive element. We'll get into this in more detail. And it goes back to the PSE and says two things. Number one, I have a valid connection. And number two, I need this much power. If it doesn't happen within a certain period of time, the PSE will say, I don't have a valid connection. I'm going to shut down my power. If the PD demands too much power from the PSE, it says, maybe I have a short and I'm going to shut down the power because I don't want to damage the product. The class, of course, is something that we referred to previously, and that is the class. PoE power is arranged in different classes. 802.3 AF has 4 classes, 0 to 3. 3 is the highest, but don't overlook that class 0, because the class 0 says I can range anywhere from the lowest class to the highest class. Class 4 is the starting point for 802.3 AT at a 30-watt source. From this point on, some of the terminology, and we'll cover this in later sessions, becomes confusing. There is another method of PoE called PoEH, and that PoEH provides power, but only if the entire system is capable of receiving PoEH. As we just demonstrated, the PSE has to communicate to the PD, so everything must be in alignment for it to work. A PoE repeater, again, focuses on data and not power. Everything that we talk about within the network environment is based on physics, regardless of the manufacturer or the product or the model number within that manufacturer that you choose to use. And some things just have a limit. As cable length increases with any capability, the power decreases. So essentially, when we talk about a PoE repeater, what we're really actually repeating is the ability of transmitting data and not PoE. So how does PoE work? Well, we just defined that in terms of that camera that we took out of the box that was in the off position, or the port that we programmed the PoE switch that had no output. PoE is a bit more complex, as demonstrated by this chart, because there's also a timing element that incorporates multiple different events that happen within those time periods. And again, if they're not received or not communicated with within that time period, it doesn't respond. Now, this brings up a whole other aspect. There are multiple manufacturers of PSE and PD chips. When they're incorporated into a circuit by a manufacturer, it will change those elements, given the fact that many of these chips don't actually operate in a similar manner. So when they're incorporated into a circuit, there might be changes, and many of those changes involve the ability of timing, as you'll see in this diagram. So things must happen within a certain period of time. And to extend out to what we told before, where the detection pulse goes across the PD, giving recognition of a connection to the PSE and giving a time element in the amount, now all of a sudden we have to have PoE provided to the extent that it's required by the connected device within that period of time. And if that doesn't happen, once again, the system will shut down. So this is an overview of how that whole process happens. One other thing, resistance is the major enemy of transmitting PoE. So within the IEEE standard, there is a standard that says that PD must relate back to the PSE, showing approximately a 22 ohm resistance. Many times you might see this in terms of 22 K ohms because it's been measured to 1,000 feet of cable. So here again, it's the resistive element from the source to the device that must be equal and maintained in order for that to happen. So let's talk about the PoE standards. And here we get a little bit more confusing because now we can see visually what we were talking about in terms of those 4 classes for 802.3 AF and 802.3 AT. Notice also that every single class that comes from the PSE has a related power that is received by the PD over that 100 meters. So if I look at class 3, which generates a source of 15.4 watts, and then is received over 100 meters at 12.95 watts, that is what's required by the full level of PoE in order to drive that device. But also notice something else. Look at the range of voltages involved. So here again, if I start off within the 802.3 AF environment, and I have a range here between 44 and 57 volts DC, which means by the time it's traveled over its 100-meter cable, it reaches the PD somewhere in a range of almost 20 volts. Well, who's to say, and where do you find within a specification, and we will be covering specifications in later part of the series, as to what specific voltage that camera or that connected device needs to turn on. A device that requires 57 volts is not going to turn on if it only receives 37 volts. And this adds to the confusion and the incompatibility between PSE sources and PD devices. Also, keep in mind that within the 802.3 AF and AT, there are different ways of running PoE. Sometimes these are referred to as the A method and the B method, and you can see these differences here. In the A method, basically we have a single pair of which 2 pairs are communicating power. In the B method, all 4 pairs are, 2 pairs are communicating power, but they're different cable runs. By the standard though, PoE equipment is supposed to be able to recognize and work if either an A pair or a B pair method. Because of the limitations of current handling capacity by 24 gauge wire, the standard upon which PoE is built on, we have a limitation. A single pair within 24 gauge wire can only handle up to 37 watts. This means that we're limited to 37 watts within the 802.3 AF and AT environment. Yet, as we all realize, there are many products that require more than that. So in 60 watts, we actually transmit PoE power over multiple pairs at the same time. It's as if we've combined the A and the B pairs together in order to provide the maximum amount of power. So if each pair is capable of transmitting 37 watts, 37 watts times 2 is 74 watts. So you can think about anything over 37 watts to begin with as 802.3 AT times 2. But here's the catch. The receiving device, the camera, which in this case is mostly PTZ, must be capable of receiving it. And so instead of having a single PD, it has multiple PDs. It has 2 PDs to receive the power from both the A and the B pair. This means also that if we were using a PSE that did not conform to sending out power in this manner, something in the camera, and I'll use the camera as the major device in this case, would not operate, or the camera itself would not operate at all. DT then builds upon this by transmitting PoE power on all the pairs within the CAD cabling. And so you could literally say that it had the capability of transmitting 37 volts times 4. In reality, most standards have headrooms for safety, and so that range is taken down to about 90 to 100 watts. Talk about the safety features, which we've touched on before. So once again, if a complete circuit is not achieved, if the PD does not send out the signals, if the PSE does not recognize the PD, in order to maintain those safety, in order not to, in a sense, occur a short, or not to incur the fact that the product shuts down, it drops off the power. Now, if you remember in that chart that we showed a couple of slides back, we showed the PoE reaching the PD on sort of a curved basis. It wasn't just one shot. And so that means that a camera has the possibility of starting up, but as more and more features come into play, if the power is not there initially for any reason, it would shut down. And we do find in some cases that cameras will start up and immediately shut down, and this is the reason why. Cabling, of course, is the most critical component within a network, and because cabling will determine everything of how we construct that network and how we need to achieve the transmission of both bandwidth and PoE. So regardless of the type of cabling we're using, as cable distance increases, so does resistance, and voltage and power decrease. Now within the IEEE standards though, it establishes those baselines. Again, 802.3 AT is 30 watts over 100 meters, becomes 25.5 watts at the camera. AF starts out in its highest level is 15.4, and over 100 meters becomes 12.95 watts. But keep in mind, these standards were developed only for CAD 5 cabling. They've extended to CAD 5E, CAD 6, CAD 6A cabling, but they were only established to those cables, of which we know consists of 4 pairs or 8 individual wires. Any other type of cable was not designed for IP PoE, but yet must meet the specific requirements. So what happens there? Well, okay, as we go higher in power, we have more cables within CAD cabling to handle it, but bandwidth is reduced. Coax cable, on the other end, because of its characteristics, is an excellent carrier of bandwidth, but again, we're only dealing with a single pair of wire, and therefore its ability to transmit PoE is significantly reduced to 37 watts maximum. Same is true of single pair cable. But with single pair cable, we have other variations in the fact that we have many different types of single pair cable. We have 24/2 all the way down to 16/2. And so the gauge of the wire will affect the distance and the ability of transmitting PoE. Keep in mind, whenever we talk about PoE, we talk about PoE that must meet the compatible standards that were put into effect for CAD cabling. And this is what we're talking about in terms of some of the criteria. We talked about the resistance element. Well, again, the cable resistance must meet at least 22 ohms. If the cable resistance rises to 33 ohms, as you see there, it will be rejected. The same is true when we talk about capacitance. And we already spoke about the key element of this, which is the voltage that comprises part of the detection pulse. And therefore, when we don't have enough of that power to drive it, and since voltage is a key element of power, we would not have the associated power to power the connected device itself. So all of this becomes a critical element in transmitting PoE over various types of cable and the limitations that are involved when we go away from normal CAD cabling. Power surge is very interesting, and unfortunately it's not something that you'll see typically in a product specification. Vigitron has done throughout the years extensive studies on surges, and surges again go back to this idea that everything we do is based in physics. Everything that we talk about within the network is based on physics. And the simple physics here is for any electronic device, it takes more power to turn on the device than it does to maintain it. But there's two aspects when we talk about something related, let's say, to an IP PoE camera. Basically, not only is more power required to turn it on than to maintain it, but many, many cameras today, if not all of them, have some form of what we call an accessory feature. That could be day-night, that could be PTZs, that could be LED turn-ons. And that power is approximately 20% more than what's usually called for within the specification. That's why understanding how those specifications are expressed becomes a very important element in the design of your network. Many, many times we find that when we talk about surges, when we talk about surges, that we don't take this extra power into account. Vigitron throughout the years and throughout its studies have estimated that power to be about 20% more than the highest power that's expressed on the spec sheet. So what happens now? Well, an installer goes out, they do an installation of all their IP cameras, everything's functioning properly. The next day, somebody comes in and 2 or 3 cameras are offline. They think the cameras are defective, and so they send it into the manufacturer. Manufacturer checks out the camera, it works perfectly, returns it to them, and the same cycle starts again. Very costly, very unproductive. What's really happening is during the nighttime, when day-night came into effect, when the LEDs turned on, what happened was the power surged. It surged over the point of the PSE's ability to provide that power. Thinking it was a short, it shut down. And with the normal equipment, once it shuts down, it basically stays down. That is, except for Vigitron equipment, which will automatically restart the process, saving time, money, service calls, and the time that a system is offline. So that the surge element is responsible for taking many, many cameras offline. So understanding the PoE spec, and again, we'll be getting into more details, we have to do a very detailed analysis when we're constructing our networks to determine exactly what's required for PoE. Does the PoE specification define the PSE or the PD? It's confusing. There's one value on there. Does that mean that's the power we provide at the source or the power the camera needs? In most cases, it's the PSE. If it's defined by class, it's most likely the PSE, okay? If the value is expressed, such as a specific value, it's most likely the camera. But keep in mind, that value does not include the surge element. Is the PSE spec defined for all camera operation modes? Okay, cameras have many different levels of PoE in different operation modes. LED on, LED off, PTZ, etc. Does it specify the power for the camera only or the camera and the PTZ? Does it specify the power for the camera only or the camera with the IR power on or off? Does it specify it if it has a heater and blower? Is the camera completely PoE powered? Many, many times at Vigitron when we're doing design center work, we receive a request and the request is, well, this camera has no local power, it's a PTZ camera, and it must operate solely on PoE. But when we look at the camera, we find out that it will operate on PoE for the camera and for PTZ, but for the heater and blower and all the other accessories, it has to have a local AC or DC supply. And what about power surges? Keep that 20% figure in mind. It will save you by providing the overhead that's required in order to operate the system and prevent shutdowns. Once again, Vigitron offers a free and without obligation design center service. We have, over the past 10 years, worked with hundreds, if not thousands, of manufacturers testing their products for interoperational testing. Again, not to determine how their product works, but how does it work within a network so that our over 250 products that we've designed fill the gap and maintain reliable operations. We can design complete networks, all IEEE compatible or integrate into any existing network. Because of the complexities involved in networking, we never use a computer program or a drop-down menu. It's just not possible. You will overlook something. So our computers are really trained engineers that will work with you on your system to give you the best and most reliable bill of materials for your system. And we encourage you to use it. The service is free of charge with absolutely no obligation that you purchase from us or the size of the system itself. What are Vigitron's advantages? Well, again, over 200 IP PoE products in every single product category. We're the only manufacturer that can provide complete network designs, avoiding finger pointing between different manufacturers, which is time and costly. Our products are designed, tested, and quality controlled in the United States, and all our local services are in the United States and North America. Because of that, we have the industry's longest warranty, production lifetime plus 3 years, which means even when a product goes out of production, you maintain a full 3-year warranty. We invite you to forward any requests you have for information. If you want answers to questions, design center support, by emailing support@vigitron.com, or as you can see, I have my own phone number and my email address. We have on our website educational white papers, and we welcome you for taking the time to view this and hope that you'll review the remaining presentations.